Welcome to Data Do Library. In today's video, we're going to talk about everything you need to know about graphs of quadratic functions. Here we go. Quadratic functions can take on many different forms, such as x squared plus 3x minus 1, 2 parentheses x plus 1 squared minus 4, or x minus 2, x plus 3. Each one of them gives you different information about what the graph is going to look like. Today we're going to mainly concentrate on the standard form of the quadratic function. The standard form of a quadratic function is some function f of x is equal to a x minus h squared plus k, where the vertex of the function is h comma k. In previous lessons, we've talked about the shift of quadratic function, how the number on the outside controls how much the function goes up and down, and the number on the inside controls how much that function goes left and right. So let's say we have y equals x squared as my regular function. That has a vertex at 0, 0. If I'm going to shift it, either k units up and down and h units left or right, opposite the direction of what you would think, that will give me a new vertex. And that vertex is going to be at h comma k. The h, or the x-coordinate of the vertex, is also the axis of symmetry, and a also tells you whether the function opens up or opens down. For example, let's take a look at the function f of x is equal to 2x plus 2 squared minus 1. Just by looking at this, we can tell that this function is moved left by 2 units, down by 1 unit. The larger the number, the more it shrinks. So if we were to graph this, I always suggest graphing the parent function first. So I know that this is a parabola where the vertex is 0, 0. The new vertex of this function will be negative 2, comma negative 1. The x-coordinate is shifted in the opposite direction of what you would think. So since we have plus here, the vertex is actually going to be shifted to the left. Knowing my new vertex is at negative 2, comma negative 1, I can go negative 2, comma negative 1. My new vertex will be here. That 2 in front also means that it's going to shrink the parent function, which if we're going to sketch it, it's just going to look like this. More often than not, you're not going to be given the function in a standard form. Normally what you'll see is something like this. G of x is equal to x squared plus 10x plus 25. To get this to the standard form, there are two ways you can really think about doing this. One is try to factor this. And if you have the same factor twice, then you can bring this function to a standard form and then go ahead and graph. And that's what happens in this example. If I factor this, I have x in both parentheses. My second sign is positive, which means I have two pluses, or 2 of whatever this sign is. I'm going to have 2 pluses. And now factors of 25 are either 1 and 25 and 5 and 5. So if I put 5 and 5 here, to check it, I'm just going to multiply the outsides and multiply the insides and add them up together. So x times 5 is 5x plus 5x. That is 10x, which is my middle term, which is how you confirm that your factorization was correct. And notice this can be written as x plus 5 squared, which means this is a parabola that is moved left by 5 units. Also notice here there is no vertical shift, it's just a horizontal shift, and there's no stretching. A in this case would be 1, which means it is just a regular parabola moved 5 units to the left. So if I was to graph this, I would go 5 units to the left and just have a regular parabola in that place. The vertex of this parabola then will be -5, 0, and the axis of symmetry, or where this parabola is cut exactly in half, will be at x equals -5. Unfortunately, quadratic functions are not always easily factorable, which means you have to use another method, and that method is called completing the square. So for example, we had some function g of x, which is x squared plus 4x plus 3. And even though we can factor it, it's not going to give me two factors that are exactly the same. Therefore, we're going to use completing the square to put this in a standard form. First thing we want to do is set this function equal to 0. Next, bring the constant term, over to the other side. I'm going to subtract 3. Notice how I left a blank space here. Something's going to go here. The formula that you're going to use to fill in that blank is -b over 2 squared. B is nothing more than the number in front of x, which in this case, it's 4. Therefore, I have -4 over 2 squared, which is -2 squared, which is 4. I'm going to take that 4 and I'm going to add it to both sides of this equation. Whatever you do to the left side, you do to the right side. Now notice the left side is easily factorable into x plus 2 times x plus 2. And the right side is 1. The left side can be written as x plus 2 squared is equal to 1. If I bring the 1 over back to the left side, I have x plus 2 squared minus 1. And that is my function g of x just in the standard form. From this form, you can see that the vertex is at -2, -1. Axis of symmetry will be -2. There is no change in width of the function. Therefore, the graph will look something like this: -2, -1, my vertex, and it's a regular U opened up like this. You'll notice that in this example, even though we know the vertex, we don't know what the X-intercepts are. And if we knew what the X-intercepts were, we could really get a very nice picture and graph, an exact graph of what this function really looks like. To get the X-intercepts, we need to put this equation in intercept form. And to do that, we're just going to try to factor. If you cannot factor this particular quadratic equation, you can use the quadratic formula. In this case, we can factor. I have x plus 3 and x plus 1. Therefore, my intercepts are at -1 and -3. I'm going to set each parenthesis equal to 0 and so for x. Which means that now I can have a really nice exact picture of what this function looks like. I have x-intercepts at -1 and -3, which I'm going to put these dots there. I have a vertex at -2, -1, and now I have a very exact picture of what this function looks like. The only piece that we're missing is what is the y-intercept. To get the y-intercept, all I have to do is just plug in 0 for x and solve for g of 0. So 0 squared plus 4 times 0 plus 3 would give me g of 0 is equal to 3. In other words, there's a point 0, 3 on my graph, which means 1, 2, 3, there is a y-intercept of 0, 3. Another way you can find the x-intercepts or the roots is to just solve for x once you completed the square. So here we have the completion of the square of this function. And let's say we want to try to get x by itself. We're going to take a square root on both sides. And notice whenever you take a square root of a square, the right side is going to become plus or minus, and that's very important here. So square root of 1 is just 1, and we're left with x plus 2 on the left side. If I subtract 2, I have x is equal to plus or minus 1 minus 2, which means there are two answers here. We have positive 1, x is equal to positive 1 minus 2, and another answer, x is equal to negative 1 minus 2. And if we solve this, notice we have one x-intercept to be negative 1, the other x-intercept to be negative 3, which is what we got by factoring. So just pausing the video here and taking a look at this example. Use completing the square to find vertex and the x-intercepts of this particular function. Hope you had a minute to do that. So to complete the square, I'm going to move the 8 over to the other side. And I'm going to use the formula negative b over 2 squared. In this case, we have negative 2 over 2, b is 2, that's my b, the number that stands in front of x, squared, which is negative 1 squared, which is just 1. So I'm going to add 1 to both sides. Notice that now factors to x plus 1 and x plus 1, and the right side is 9. X plus 1 can be written as x plus 1 squared, which is equal to 9. From here, if I move the 9 over to the other side, I now have a standard form of my quadratic equation, which would give me x plus 1 squared minus 9. That would give me the vertex of negative 1 comma negative 9, which means this function is shifted to the left 1 and down 9. If I solve for x from this point on, I can get my x-intercepts, which means I'm going to square root both sides. I have x plus 1 left, and on the right side I have plus and minus 3, and I have two answers now. I have one, x plus 1 equals positive 3, and the other one, x plus 1 equals negative 3. If I solve for x, I have x equals 2, and the other one, x equals negative 4. Now you know your x-intercepts, and you know your vertex. Now you have a pretty good idea of what the graph is going to look like. I have x-intercept at 2. I have another one at negative 4. I also have my vertex at negative 1 comma negative 9. Which will be all the way down here. I can graph this function. The only question we didn't answer is what is the y-intercept? And to get the y-intercept, all I have to do is plug in 0 for x. And when I do that, I'm going to get 0 comma negative 8 being my y-intercept, which means there's a point here, 0 comma negative 8, that crosses the y-axis. Let's try one more example in which you have to find the vertex, the x-intercepts, the y-intercept, and the graph. So the first thing we're going to do is set this equation equal to 0. So x squared minus 18x plus 80 equals 0. We're going to move 80 over to the other side, which is negative 80. And we're going to find what goes here in the blank space. So again, the formula is negative b over 2 squared, which is negative 18 over 2 squared, which is 81. Means I'm going to add 81 to both sides. Now I'm going to factor the left side. And notice the reason why we did that is so we have a repeating factor. I have two negatives because we have this sign being negative and this sign being positive. So the second sign is positive. You're going to have two of whatever the first sign is. In this case, it's negative, so two negatives. And factors of 81 that are going to add up to 18 are 9. And on the right side, I have 1. So the left side can be written as x minus 9 squared is equal to 1. That form gives me vertex. So if I move 1 over to the other side, I now have a standard form. Therefore, vertex would be 9 comma negative 1. And if I solve this for x, I can take a square root of both sides. I have x minus 9 equals plus or minus 1. And again, I have two answers of x minus 9 equals positive 1 and x minus 9 equals negative 1. So add 9 to both sides. I have x is equal to 10, and the other one, x is equal to 8, with vertex of 9 comma negative 1. That will give me a pretty good idea of what my graph is going to look like. The only other thing you may want to do is to find the y-intercept, which in this case will be 80. Because if I plug in a 0 for x, I'm going to have 0 comma 80, which I will not be graphing. I'm going to run out of room here. So x is 8 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 8 being one of the x-intercepts, y being the other one. 9 comma negative 1 will be down here, that being negative 1. And notice this is my parabola. It opens up and you can see the y-intercept will be all the way out here. Another very common example is when you're given a vertex and then one of the points that the function passes through, and you ask to find what is the equation of this quadratic function. In that case, you know that vertex is going to give you letters h and k in the standard form. Therefore, I'm going to leave a alone for a minute. I'm going to replace h with the negative of what that x value is, because again, it goes the opposite of what you would think. So this is really x plus 3 squared minus 14. Now we've taken care of the vertex. Let's use that point that they gave us and find out what a is. So f of x is nothing more than y is equal to a x plus 3 squared minus 14. I'm going to replace 0 for x and 4 for y in my equation, and that will give me a. So what I would suggest is put a little star next to it. And now instead of y, I'm going to write 4 is equal to a 0 plus 3 squared, that's my x value, minus 14, and solve for a. So 4 is equal to a times 3 squared minus 14. 4 is equal to 9a minus 14. Add 14. Therefore, we have 18 is equal to 9a. Divide both sides by 9. A is 2. So go back to that start equation and fill in a, and you will be done. So my function f of x is equal to 2x plus 3 squared minus 14. So this function is moved left 3, down 14, and it shrinks by a factor of 2. Try the next example on your own. Okay, so here we have vertex of negative 5 comma negative 2, which means my h and k will be changed into the vertex. So a, x, Negative h means the negative of the x-coordinate of the vertex, which would be plus 5. Again, it goes the opposite of what you would think. And then minus 2 is my k, and that is my function y. Now I'm going to use the point and use the coordinates x and y to replace x and y in my start function here. So y is 0, a is, we don't know. We're going to try to find that out. X is negative 4 plus 5 squared minus 2. So 0 is equal to a 1 squared minus 2. 1 squared is just 1, so a minus 2 at 2, and a is equal to 2. Now I'm going to go back into my start equation, and I'm going to rewrite it with a replaced in. So y, or f of x, let's use f of x. F of x is equal to 2 x plus 5 squared minus 2. Thank you again for joining me. Make sure you like and subscribe. I hope to see you next time. Take care.